Hello, everybody. Thank you so much for joining me this morning. My name is Jasha Karasek. I'm a winemaking specialist with Enartis USA. And the presentation I'm giving this morning is sort of a follow-up to Dr. Clark's presentation that you just saw. My presentation is sort of a subset of the discussion that he had on copper and different forms of copper. And the presentation is about the impact of copper removal on canned wine shelf life. So for the agenda today, I'm going to talk about opportunities for canned wine and why canned wine is on winemakers' minds at this time. I'm going to talk about canned wine and its challenges, some of the copper removal trials that we have done and looked at for copper removal and canned wine specifically. I'll talk a little bit more about copper and wine and sort of open up a couple of discussion topics about copper and wine, and then some more topics sort of going forward and how we can potentially progress with this package segment in the industry. So some of the opportunities for canned wine are that it's a market segment that continues to grow rapidly. So it's been doubling nearly every year now for the last 5 years, and it continues to grow. Last year, the growth slowed a little bit, and that was actually due to some shortages that were in the market for cans, and so we expect that this segment will continue to grow over the next foreseeable future. Second point is that the TTB this last year has approved more package sizing for the industry. So this opens up additional sizing in terms of cans that are like 333 milliliter cans that are more commonly seen in the market in other beverages, and then other sizing options as well. So this is just going to open up canning even more to wineries going forward. And then the can format also offers a unique market placement for wine in the sense that cans are more portable, so they can be taken on picnics and outings and things like that. It's an easy to open and pour sort of format, so it's going to work well for events and sporting events, things like that. Airlines. So it offers a unique sort of placement for wine. Also, it puts wine next to other beverages that might be popular as well, such as seltzers, beer, and so it offers a new way for winemakers to reach out to consumers. Other opportunities include variety packs. So we might see wineries being able to introduce different varieties because of the smaller package sizing, tasting kits, things like that. So it's opening up new things and new avenues for winemakers. But that doesn't come without its own set of challenges. So there's a couple of things that winemakers need to consider when it comes to canned wine. Mainly some of the technical winemaking factors. Two main things that need to be considered are it's a highly reductive environment. So we're talking about zero oxygen transfer. And then also talking about liner integrity and compatibility. So if you're not familiar with cans in general, we have an aluminum exterior with a liner interior that coats the interior of the can and prevents the beverage from coming in contact with the aluminum surface. And so the integrity of that liner is quite important because aluminum can be a reactive metal, and we don't really want it coming in contact with the product inside. However, we have seen some challenges in the wine industry in terms of some questions as to whether or not wine is compatible with the current set of liners that are available to the wine industry. And we know this because we've seen in trials and data that there tends to be an increase in aluminum over time, a small increase, nothing too dramatic, but enough to kind of show that there is some contact being made between the aluminum and the wine potentially. And so the liner integrity and compatibility is a big concern for the industry going forward. And those liners will continue to progress over time, but until we can get a liner that's more specific for wine, we may continue to have some of those challenges and need to consider those things. Other challenges include marketing and distribution. So canned wine, what we're going up against is the perception of canned beverages. So many consumers have been exposed to Coca-Cola and beer and other things that are inside of cans. And in general, probably what the industry needs to consider is that people might store wines like they would those cans. They might treat those wines like they do those other canned beverages. And so the storage of the product might be really important for that reason. And we need to consider that the temperature is probably going to be, could be less than ideal in many cases. And we have seen in trials recently and in the past that temperature plays a large role in the shelf life of canned wines. And so winemakers need to be aware of this and, you know, keep this in mind for trials that they're running or for their product in general, is that since winemakers don't have control over temperature after the product leaves the premises, we need to consider that we need to make wines for that situation. And we do this already kind of with tartrate stabilization and things like that. We make wines so that, you know, they can endure colder temperatures for prolonged periods. We might need to make our wines so that they can endure slightly warmer temperatures, potentially retail settings for extended periods of time. So what we've learned so far about canned wine is that canned wines can have shelf life sort of challenges. Hydrogen sulfide has been the most reported and prevalent. So this sort of eggy characteristic has been definitely the most reported and prevalent for canned wine. Oxidation has also more recently been reported, and we think that this is in response to some of the winemaking that has changed for canned wines recently, because we know that SO2 is important for shelf life of canned wines. We think winemakers have been decreasing the SO2, and we may be having some oxidation because of those issues. But hydrogen sulfide is still the bigger problem that we need to sort of tackle. So some of the factors that lead to elevated H2S, we believe for canned wines is SO2 and its possible interaction with aluminum can forming H2S. We've seen in work done from researchers at Cornell, Gavin Sachs, Rachel Allison, that SO2 is able to interact with aluminum and form hydrogen sulfide. So we know that that's an important factor. We've also seen work done in Australia at the AWRI. Eric Wilkes and Neil Scrumjauer have also shown this interaction as well. So we know that SO2 is important. The concentration of SO2 is important for this interaction with aluminum forming H2S. And we also know that copper-bound fractions are a potential problem as well. Again, the researchers at the AWRI and also Dr. Andrew Clark have shown that copper-bound fractions can be problematic from a hydrogen sulfide standpoint. And so we suspect that there's a re-release of those sulfides happening in a reductive environment. And it's possible that the can environment specifically might be enhancing some of those situations as well. So the copper-bound fractions we know is a issue as well. So kind of getting into some of the trials that we've done on canned wine, trying to address the reduction issues specifically by dealing with copper. And a recent trial that we've done on 2019 white wine that was canned had initial copper levels of 0.08 milligrams per liter, which is fairly low copper actually for many wines. So this was an interesting sort of example because we were starting with an already very low copper level. This copper measurement was done before we had the capabilities to do Dr. Clark's method. So going forward, we will be looking at copper-bound sulfides from both the total level and a free level as well. Or I should say sulfhydryl free or sulfhydryl bound level. So going forward, we'll be looking at that, but this had a very low level of copper to start with. So we treated that wine with Clairol HM, which I'll go over in a couple of minutes. It's a fining agent that contains PVI, PVP, and pre-activated chitosan. It's a metal removing fining agent that works well for not only copper, but copper-bound sulfides. We treated that wine with Clairol HM at 25 grams per hectoliter and compared it to a control over an aging period of 9 months and tracked the H2S over time to see how the H2S would be changing, since that was our target for sort of tracking. So a little bit more about Clairol HM. Again, it's a blend of PVI, PVP, and pre-activated chitosan. And the reason for the blend is that PVI, PVP, and chitosan have both been shown to remove metals and work in sort of different wines, preferentially for metal removal. And so this blend of the two actually works on a more broad range of wines compared to just the PVI, PVP alone. So this is a specific blend that we think works quite well for canned wines as well. And both of these both of these finding agents are metal removing agents that can remove copper-bound sulfides. So in our copper removal trials, again, we compared the control to the Clairol HM over time. This was stored at 68 degrees Fahrenheit, which is sort of retail temperatures. It's elevated temperatures, warmer than what we would see in our cellars and our warehouses, but it is what we might see in the retail environment. And what we saw was a fairly dramatic increase in hydrogen sulfide at 4 months between the two treatments. And then at a total of 7 months, we saw actually a dramatic increase as well of H2S, where the Clairol HM treatment had very little H2S over this period of time. So we think that this is actually a fairly good treatment for eliminating the H2S in this wine specifically, but potentially in other wines as well. So a lot of times I hear from winemakers when I propose this potential solution to look at copper is that they don't add copper to their wine, and so they're not concerned with it. But consider that copper is a naturally occurring metal that can come, from the grape juice. There's varying levels in different grape juices, just depending on the variety, the source of the grapes, whether or not you're farming organic, because organic vineyards tend to spray with copper as a fungicide. And so those copper levels can be elevated. And so just consider that it's a naturally occurring metal as well in grape juice. And the grape juice levels will vary. After clarification, you'll have less copper, and even after fermentation, you'll have substantially less, as Dr. Clark pointed out in his previous presentation. So we show that yeast can absorb it, but there's also some potential that, possibly that that copper might be binding to some sulfides in the fermentation. It might be, sort of remaining in the wine post-fermentation as well. So this is sort of a question that I hope we can sort of address in the industry, because now that we know that copper that is bound to sulfides doesn't just precipitate out or is not just removed with racking, we need to consider, what's the earliest time point that we start to see these copper-bound sulfides show up, and sort of track them over the course of the wine's life as well. So what we learned so far about canned wine, we know that copper has an important role to play. We know that sulfites have an important role to play. We think that we've addressed, slightly some of the reduction issues that we might see in canned wine. We're interested to kind of see on a broader scale how well the Clairol HM works in terms of eliminating reduction across, multiple different wines, multiple vintages. But so far, we've been getting very good reports from winemakers who have been using it. And now we are going to move on to trying to solve some of the more oxidative issues that we've been seeing in wines as well, which we think is related to lower free SO2 levels in canned products in general. So things to look at next, we want to benchmark copper-bound sulfide levels for treatment with Clairol HM. We want to know what level do copper-bound sulfides become problematic. Is it just very low levels? Can it be higher levels? And so we think that Dr. Andrew Clark's method, the colorimetric method, could be useful for that purpose. We also want to address the low SO2 requirements for canned wines and try other enological tools for preventing oxidation pre-packaging. Other things for the industry to consider, there's never a second chance for first impression. And this goes for new wine drinkers that are coming onto the market and individuals that are also new to trying canned wines. I just want to encourage the wine industry to share information with other wineries and try to understand, the best sort of treatments that we can give to canned wines, because ultimately the rising tide will float all boats in this segment, and sharing information is going to help progress the industry for this package segment. And we don't really want to shoot ourselves in the foot as an industry by having some of these shelf life issues for this segment and give people the wrong impression of canned wines. So I'd encourage us to just continue to share information and work on this problem. Let's understand the role of copper in its various forms for shelf life, not only in canned wines, but also screw caps and other low TR settings. We know from work that Vicente Ferreira has done in Spain that these copper-bound sulfides can release in reductive environments. And so let's look at other reductive environments and see if these are problematic there as well. And then, this new colorimetric spectrophotometric method for analysis could reveal really better information about copper sulfides, and is available to more wineries. In terms of most wineries have a spectrophotometer. And so I'd encourage the industry to look at adopting this as a means of looking at copper, specifically for canned wines as well. And then not all wines may be appropriate for the can environment. So if you're trying to put a wine into can that has very high SO2 levels, very high copper sulfide levels without any treatment, and then a history of sulfides and a problematic variety, I would just consider looking at other options, or make your wines specific for cans so that you have lower SO2 levels. You've looked at copper sulfide or treated for it, and you've looked at the variety and everything more closely. I want to give a special thanks to Andrew Clark and his students and staff at Charles Sturt University for their contribution to this sort of discussion about copper sulfides and all the work that they've done for developing this method for copper sulfide analysis. I want to thank Dr. Gavin Sachs and Rachel Allison from Cornell University and their work that they've done in canned wines, looking at the reactions between aluminum and sulfites. Dr. Eric Wilkes and Neil Scrimgeour from the AWRI and the work that they've done on copper-bound sulfides and canning and removal of PVI, PVP. And then I want to thank the EVA Forum for giving me the opportunity to present today, and thank you for your attention.